Welcome to Chapter 4, Compounds and Their Bonds. This video is on Chapter 4.1, the octet rule and ions. In nature, atoms of almost all elements on the periodic table are found in combination with other atoms. And these compounds are a result of the formation of bonds, or chemical bonds, between two or more different elements. Okay, atoms that are not noble gases want to form octets. And we're going to talk about this in just a second, what an octet is and what the octet rule is. And they want to form octets to be more stable. So they do this by losing, gaining, or sharing their valence electrons. So if you remember from Chapter 3, your noble gases are stable because they have a full valence shell. So they have 8 electrons, which hence the term octet comes from, except for helium. If you remember, helium's up on the first row, and it only needs 2 electrons to have a full octet. Okay, and so for octets, for the rest of our elements are going to want to have a full octet of 8. Okay, and so atoms are going to lose, gain, or share electrons by forming 2 types of bonds, either an ionic bond or a covalent bond. And the reason for this is because atoms have a tendency to want to obtain a noble gas electron configuration. And so basically, all the elements want to be like the noble gases. They want to be stable like the noble gases. An ionic bond occurs when atoms of one element lose valence electrons and the atoms of another element gain valence electrons. Okay, and so basically, in shorter term here, 1 second, let me get my computer's being slow. Okay. And so basically an ionic bond is the transfer of electrons. And usually this occurs between a metal and a non-metal. Covalent bonds occur when 2 non-metals, or 2 or more non-metal atoms, share electrons. So this is the sharing of electrons to obtain a noble gas arrangement. Okay, so that's all the octet rule really means, is that all of the elements want to have this stable and full octet of electrons like the noble gases. Okay, and so an ionic bond is the transfer of electrons to obtain this configuration, typically metals and nonmetals, and covalent bonds are going to share electrons in a chemical bond, and we're going to look at those in detail later. So the octet is 8 valence electrons. It's associated with the stability of the noble gases to have 8 electrons, except for helium, which we've already stated. Okay, so if we look at our valence electrons and we go here, we see that helium wants to have 2 valence electrons. So these are all of our noble gases. So if you look at, you want to go ahead and pull out your periodic table. If you look at periodic table, your group 8A, if you go down, you'll see that they all have in their last shell of their valence electrons, they have 8 electrons, except for helium that only needs 2. Okay, so this is kind of a busy slide. I'm going to try to break it down for you to show what's actually going on. Okay, if we have a metal, okay, so I'll go ahead and just state this and we'll look at more examples. But if we have a metal, so if we look at magnesium, so we're looking at magnesium and we find that it is in group 2, okay, and it is going to lose electrons. It's actually going to lose 2 electrons. Okay, so if we look at magnesium, it has an atomic number of 12, so it has 12 protons and 12 electrons. In order for it to have a noble gas configuration, it's going to have to lose 2 electrons to be like the nearest noble gas, which is neon. Okay? And so if it loses 2 electrons, it's going to have now 10 electrons. Okay, and if we look at 10 on the periodic table, that would mimic the number of electrons that neon has. Okay, for chlorine, it is a nonmetal. It's going to be on the right side of the periodic table. And its atomic number is 17. Okay. If it gains 1 electron, it can be like the nearest noble gas, argon. So it's going to gain 1 electron. So if you look at your periodic table, this kind of helps show this a little bit better. Okay, so chlorine's here. This is one we just discussed. Okay, and so if it gains 1 electron, think back to chapter 3 in your electron arrangements. If it gains 1 electron, it's going to be like the nearest noble gas with respect to electrons. Okay, it's still chlorine, okay, but it's going to gain an electron. Okay, magnesium wants to lose 1, 2 electrons to be like neon. So if it loses 2, then it becomes, its electron configuration looks like neon. Okay, with saying this, metals, just stated this on the last slide, but form positive ions by losing valence electrons. The easiest way for a metal to get to have an electron configuration like the nearest noble gas is by losing their valence electrons. Okay, electrons are negatively charged. Okay, so if we lose negative charge, we're going to form positive ions. Okay, so metals lose electrons, they lose negative charge, and so they are going to form positive ions, or have a positive ionic charge. And not only this, we've used our periodic table and we've seen how in chapter 3 we can determine trends and we can determine configurations from the periodic table. But not only this, we can also look at the periodic table, and for our group 1A, 2A, and 3A metals, we can use that group number, which corresponds to the ionic charge, or the ion that that metal will form. Okay, so if we look back at the periodic table, in group 1A, okay, minus hydrogen, remember it's kind of lost on the periodic table. Sometimes you'll see it over here, and sometimes you'll see it moved over here. Okay, but it is a nonmetal. Okay, so everything below here and down, so anything that's in the blue is a metal. Okay, and so it's going to, in group 1, it's going to lose 1 electron to form a +1 charge. All the metals in group 2 are going to lose 2 electrons and form a 2+ charge. Then we skip over, because see, here's our B elements. Okay, we're not concerned with those at this point. We're going to skip over to our group 3. Okay, so all the metals in group 3 are going to lose 3 electrons and form a +3 charge. Okay, so if we look at magnesium, again, it's got 12 protons, 12 electrons. We see its arrangement here. Okay, but it doesn't have a full octet, right? We've got only 2 electrons in this third energy level. And so it's going to have to lose 2 electrons in order for it to have a stable configuration. Okay, so if magnesium loses 2 electrons, then it's going to have 10 electrons. So we lose 2 electrons. And it's going to have 10 electrons, just like we have shown before. But we represent the magnesium ion as Mg2+. That 2 accounts for the charge for those 2 electrons that were lost. So metals, like we said, form positive charge based upon how many electrons that they lose. Okay. It's the opposite for nonmetals. Okay, nonmetals, remember, to the right of our stair step on the periodic table, these form negative ions because they want to gain electrons. Okay, so if you gain negative charge, then they're going to form negative ions. And they do this so that they can have the configuration of the nearest noble gas. So once again, this is just the octet rule. Okay. So if we look at our group 5, okay, so we're not going to, we can't look at group 5 and say that they form a 5 negative charge, okay, but we can look and we can see a trend. So I'm actually going to go to the periodic table to show this a little bit better. Okay, so if we look at group 5, okay, they want a configuration. Here's our noble gases. Everyone wants to be like the noble gases. In order for group 5 to obtain this noble gas configuration, they have to gain 3 electrons. So 1, 2, 3. Okay, therefore, your group 5 elements are going to form a negative 3 charge, okay, because they gain 3 electrons in order to be like the nearest noble gas. Okay, so I just use nitrogen as an example there, but it's all of the nonmetals in group 5. Okay, in group 6, okay, we're going to need 2 electrons. So all of your nonmetals in group 2, so oxygen, just going to use that as an example, form a 2- charge. And then for group 7, they're only 1 electron away from the nearest noble gas. And so if we did bromine here, we have a negative 1 charge. And when they have a negative charge, we now call them, instead of bromine, it's called bromide. Okay, we'll learn more about naming here soon. So group 5 nonmetals form a negative 3 ion, group 6 a negative 2, and group 7 a negative 1. Okay, because they only need 1 electron to have 8. Okay, so 7 plus this 1 gives us 8. So we have 6 valence electrons plus 2 gives us 8. Okay, so all we're doing here is getting 8 valence electrons. Okay, so this just shows chlorine. A chlorine atom has 17 electrons, wants to have 18, so that it has 8 in its valence shell, so it wants to gain 1. So it gains 1 electron to form a chloride ion. Okay, and so we represent this by showing the charge, a negative 1 charge. So our group 1, 2, and 3, A, our representative elements, form a +1, a +2, and a +3. Hence, metals form positive charges by losing electrons. Okay. Group 5, 6, and 7 are nonmetals that form negative charges by gaining electrons. Okay, so we can look at this in kind of a table here where it just shows you that they want to, examples of these ions and their nearest noble gas. So if you look at group 1, okay, so lithium, the nearest noble gas to lithium, if you take away an electron, so you have 3 to begin with, and you take away 1, it's going to look like helium. So it just shows that it's 1 electron away from, so it's going to lose this electron to being like a noble gas, the noble gas helium, to be exact. Okay, and so if we look even as we go down at calcium, has a 2+ charge because it's in group 2. So it wants to lose 2 electrons to be like its nearest noble gas on the periodic table, which is argon. Okay, so we can go down and do all the rest of those, but hopefully you're seeing it so far. Okay, let's just pick sulfur. Okay, it's in group 6. It needs 2 electrons to be like the nearest noble gas. So its charge would be S2 minus, would be its ionic charge, and that's because it needs 2 electrons to be like the nearest noble gas. So it wants to gain 2 electrons. So hopefully you're seeing this trend. All of our group 7 have a -1 ionic charge. All of our group 6 here have a -2, and group 5 a -3, based upon how many electrons they need to gain to be like the nearest noble gas. Okay, so now we're going to practice. We're going to write the formula and a symbol of an ion with 16 protons and 18 electrons. Okay, you can stop the video if you'd like to practice this yourself. Okay, 16 protons, that's the identity of an element. So we're going to look for 16 on the periodic table, which corresponds with the element sulfur. Okay. And this time we have, usually when we've seen with our neutral atoms, if you remember me saying that, it was important because now we're going to look at atoms that are not neutral. We're looking at ions. And so we have 16 protons and we have 18 electrons. So basically, normally we've seen 16 protons and 16 electrons. We've seen them to be identical. But now we have 18 electrons. So this means that we have gained 2 electrons. So we have to show this. The sulfide ion has a 2 minus charge because it's gained 2 electrons. So this would represent 16 protons, because that's the identity of sulfur, and 18 electrons because we have 2 extra electrons. Okay, the last practice problem has got 4 parts. We're going to consider the element calcium and chlorine. So we have a metal, first thing you want to look at that here, and we have a non-metal. So that's the first thing you want to do is recognize. That's actually part A, is identifying as a metal or non-metal. Calcium's in group 2. It's on the left side of the stair step on the periodic table. It's a metal. Chlorine, a non-metal, on the right side. Okay, now we want to state the number of valence electrons for each. Okay, we learned this in chapter 3. Okay, so for part B, for our representative elements, all we have to do is look at the group number. Okay, calcium is in group 2A, and so it has 2 valence electrons. Okay, for chlorine, it's in group 7A, and so it has 7 valence electrons. Okay, part C, we want to state the number of electrons that must be lost or gained for each to acquire an octet. Okay, first you want to think about, okay, is our metal or our non-metal going to lose? Which one's going to lose? Which one's going to gain? Okay, we know that our metals lose. So metals lose electrons. Okay, so let's go ahead and have part B here, but write out this is calcium. Okay, it's our metal. So we know that it's going to lose electrons. Okay, since it's in group 2, it's going to have to lose 2 electrons to be like the nearest noble gas, argon. Okay, so it's got 2 valence electrons, and it must lose 2. Okay, for chlorine, we can't just look at the group number. We go and we can look at chlorine and see that it's in group 7, and it just needs 1 more electron to have a full octet, because it already has 7, it just needs 8, and so it would gain 1 electron. And so we show this ionic charge whenever we write the symbols for these ions, and we have to represent the electrons that are lost or gained. So if we look at calcium, it loses 2, and so it has a 2+ charge. Metals form a positive charge, ionic charge. Okay, our non-metal is chlorine, and it's going to have a -1 charge. Okay, metals form a positive charge, non-metals form a negative ionic charge, and these would be the resulting ions. This concludes this video, and we'll be moving on to section 4.2.